This video is about the Optimize Parameters Grid operator. This operator allows you to find the optimum parameter set for an operator under investigation by using a brute force search through all the possible combinations of a parameter set of interest. This can be used, for example, to find the best parameters for a learner such as one based on a support vector machine. The operator under investigation must be combined with other operators to produce a performance vector. The optimized parameters grid operator then makes use of this by trying all combinations of the parameter set of interest for the operator under investigation and uses the best performance to select the optimum parameter set. As the operator executes, the log operator can be useful to illustrate how the operator functions. In addition to the best performance, the output from the operator is a set of optimum parameter settings for the parameter set of interest. These can be saved for later use, where they can be applied to another operator using the set parameters operator. A bit of a mouthful. Easier to see it in action. So we'll firstly look at the edit parameters settings for the actual operator itself. Then we'll actually look at the operator doing its job, and we'll observe it by using the log operator. The result of the operator is some parameter settings, so we'll see them being saved. Then we'll see them being used to set the parameters of another operator. And just to prove that it all works, we'll use the xPrediction operator with those parameters just to see what happens. Let's start with the process. So here is a process. If I press the execution order button, at a high level, the process retrieves the sonar sample data set, splits it into two. 70% goes to the optimized parameters operator, 30% goes to an xPrediction operator here. Once the optimized parameters grid operator has done its work, a performance vector gets output. Some logging is done, we'll look inside that shortly. The key output is a set of parameters, the optimum parameters that the optimized parameters operator has found. So they get stored here. Actually, there's a storing in the repository here, and I recall I stick it in the process's memory here. I then retrieve it. This is a superfluous step, but it just shows how it's done. And then I use the set parameters operator here to set some parameters for an operator that's inside this xPrediction operator. And then finally, because obviously we know what the 30%, we know the actual correct labels, we can actually see what the performance is now on that, which is what the output will be here. Okay, so let's look at the optimized parameters grid parameter settings. So here there's only one parameter, it's called edit parameter settings. So what you do is this. Inside the optimized parameters grid operator are some other operators. You can see them listed here. And what you do is you decide which are the parameters of interest for one or more of the operators. So I've already chosen, there's SVM gamma and SVMC, and in principle what you can do is you can select any of the parameters, and if you, by clicking that green arrow there, that would appear on the right here. I'm not interested in degree in this case, so I'm just going to leave gamma and C. And then what you do is you, by filling in this grid here, you choose what values you'd like to try for the C parameter in this case, and obviously for gamma this is what the choices are for that. Having decided what parameters you want and what steps you'd like, the optimized parameters grid operator itself will then just try all combinations. So you can see here there are 15 times 16 steps, I guess, times 16, so there are 256 combinations, and you can see that happening here. So what this means is that the optimize parameters grid operator will execute its inner operators 256 times. Let's look inside it though, just to make sure we understand what's going on. So inside there's a cross-validation operator, which is called estimate performance, which is what cross-validation is for. And there's a log operator. Inside the estimate performance, it's actually quite straightforward. There's a support vector machine, and I'm applying the model. I'm calculating performance for that fold here. And this is the operator which will have its parameters changed. So gamma and C for the support vector machine will be changed by the optimized parameters grid operator. If I go out to the level above, so that if you recollect, this is inside the optimized parameters grid operator. This is the first level in. The log operator is simply going to record the performance that it sees from the estimate performance cross-validation, and then it will also record the value of C and gamma from the support vector machine that have been chosen or selected by the optimized parameters grid operator itself. So each time the optimized parameters grid operator executes one iteration of its internal operators, there will be a log entry written. Let's just see that happening. So I'm running the process now, and you can see here down the bottom it's going to run 256 times. It's got to 32 so far. So if I go to the results view quickly, you should see a log being written. And if I go to the table view, you can see it's 81, 84. So it's adding a new row each time with the combination of C, gamma and the estimated performance. And of course I can plot that. So if I put C as the domain dimension, gamma as the y-axis, and if I put estimated performance as the size and the color, and if I also set logarithmic and for both dimensions, because I'm using that, you can see that each time each iteration is adding an additional set of points that I'm plotting, and you can see the size of them, the colour is indicative of perhaps where the best performance is, and it's looking like somewhere around here, or maybe it's here actually. If we let that run to completion, so it's at 215, it's got a little bit to go. At the end we'll see the final result, looking as though it's nearly done. I'll pause actually this video at this point because it's a bit slow. So it's finished now. So the log completed. So the full view of what happened is here. So clearly there's something about this row here perhaps gives the best performance estimate. The actual performance vector that's been output from the optimized parameters grid operator is here. It's basically estimating that 91.58 bit, 92%, let's call it that, which is very good. And now let's look at the parameter set that was output from the operator. Now that's come out here, and I've stored that in the process context. I've recalled it here, but we can actually look at it because I've stored it in the repository. In fact, it's here. If we look at the date and time, it is indeed 11:15. So trust me, it wrote a new parameter set into the repository as a result of me running this process. And we can even we can actually click on it, we can actually show it here. Let's just show it just for fun. So this is the actual parameter set that's output from the optimized parameters grid operator. So you can see the 91.58% has been recreated here, and you can see these are the values of the parameters for the support vector machine that yielded that best performance. If we now go back to the design view, we can see how to use that parameter set. So basically the set parameters operator is the thing you would use for that. What you do is you choose two operators, so you have to know the name of the operator from which the parameters would derive, which is the left hand side here, SVM, and you then also have to know the name of the operator to which the parameters will be applied, which is this one here. To prove that, so SVM2, that's actually contained in this X prediction. There it is, SVM2. And as a result of actually executing the set parameters operator, the value of gamma and C have been set to the values that the parameter set indicated. All good so far. And then what's happening is that the X prediction operator is then doing an estimate of the performance using the 30% of the original data. So there's no possibility of any overfitting. So the performance we'll get here is actually the real performance, that the model that's been chosen in this optimized parameters grid. That's actually the real performance you would expect to see on live data. So if I go now into the results view, the real performance is actually somewhat lower, sort of 74%. And you can see here, here's the prediction from the output from the cross prediction, the X prediction. So you can see here the class and the prediction aren't always correct, and that's reflected in this performance vector. So this teaches us the importance actually that the estimated performance is likely to overfit. It depends on the situation you're in. So the real performance you'll get will never be right, and this of course leads to the question, is the actual optimum parameters set, is that really the right one? And that's a harder question to answer. But simply by observing this, you can see actually you have to be careful. Nonetheless, the brute force selection of optimum parameters is actually quite a cool way of really quickly getting to a good answer in terms of support vector machines, and of course it's applicable to other learners as well, where the parameters are somewhat tricky to get right. So I'll leave it with this log view, and you can see how C is varying along the bottom and gamma on the left here, and you can see the size and the color reflects the estimated performance.